Okay, 2.4, operations on higher index radicals. So 2.1, we did square roots. 2.2, we did 3 and 4. Then 2.3, we did operations on square roots, and now we're, again, just expanding to 3 and 4. All right, so really not much different, not a lot of new stuff here, just on a different index number. But we're still going to have some square roots in, like number 1. So first off, we're going to simplify. So again, this is going to simplify to 4 and 5. And it's going to break down to 9 and 5. And of course, square roots on both of them. I don't always do this because, it gets a little sloppy. And I'm already sloppy enough. But, square root. So square root of 4 comes out as a 2. And the x was already out there. And we have the 5 trapped inside. Don't forget the minus sign. Now, the square root of 9 is 3, but also we have this 2 here, which we're going to divide by 2. That means one group is coming out, and we have this. Now, notice, we have radical 5, 2x, 3x. So, 2x minus 3x is negative 1x, square root of 5. Final answer. Now, notice on this one, we have cubic, so our numbers are going to be different, so don't write this down, we're not going to do 4 and 10. Okay, that's a no-no because that's for square root. 4 is not on our chart. If you look at your chart on the cubic row, there's no 4 there. There is an 8. 8 times 5. And then 625, it's going to be 125 times 5. Don't forget to bring this down. Okay, and this definitely gets sloppy, trying to put cube root here. You know what I mean. Okay, these are all cube roots. So the cube root of 8 is 2. Times the 3 is 6. And then we have the x out there. Okay. And then the root 5 is stuck inside. And remember, it's a cube root 5. Don't just write root 5. You have to put that 3. It's very important. You will lose points if you don't have that 3 there because it is a cubic root, not a square root. Now, on the second one, don't forget there's a 2 here. The cube root of 125 is 5. Times 2 is 10. We have the x there, but we also have a group of 3, which will come out as a group of 1, which gives us x squared, and then the root 5. Now, we cannot combine these. Yes, they both have a root 5, but this has an x and this has an x squared. So that is as far as we could go. That's it. Now, if I made this a 2 out here, x squared, then I would get 16x squared cube root of 5. That would be my answer. 6x squared plus 10x squared is 16. But that's not the answer because we don't have the same value outside the radical. All right, here we have a 4th root. So again, we don't have a lot of numbers there to use, all right? But we're going to check and see what we have. And if I take my first number, I wouldn't use 625. But if I take 768 and divide it by 256, I get 3. Now remember, we don't use 4 here, okay? And we're not even going to use 8 times 6 because that's a cubic. We're going to use 16 times 3. Now, don't forget that there's a 4 out here. Bring that down. So the 4th root of 256 is 4. Times the 4 that was already there is 16. Now we're going to divide the 9. 9 divided by 4 is 2 groups of 4, which is going to leave 1 left over. So we have a 4th root. Don't forget that. The 3 is stuck inside, and 1x is still stuck inside. All right, minus the 4th root of 16 is 2. There's an x out there already, and we're going to be able to squeeze one more group out of there. leaving x squared on the outside. And then fourth root, don't forget that, 3, and there's still an x left over. Now notice, fourth root of 3x, fourth root of 3x, x squared. We can combine these. 16 minus 2 is 14. The x squared, don't forget that 4, 3x underneath. Final answer. All right, a lot going on here. This is a cubic root, okay? We have a 2 and an x coming out. Don't forget that. 27 and 2. Now, of course, these are cube roots. I'm not writing all that because it gets a little cramped. I want you to be able to see it clearly. All right, 375 is 125 times 3. 16, remember, cube root, that's 8 times 2. You can already see that these two might have the possibility of going together. The middle one will not. Okay, back to the start. 54 is 27 times 2. The cube root of 27 is 3 times the 2 is 6. Now, we already had an x out there. We have one x underneath. It cannot come out, so it's stuck. So we have a 2 and an x stuck inside. Minus. The cube root of 125 is 5. Now this time we do have 3 divided by 3 is 1. One group of 3 came out. Okay. And we have a 3 stuck inside and no x. Okay. So definitely will not combine with the first one. Different number and also no x. Then we have a plus. Don't forget this 2. The cube root of 8 is 2 times the 2 is 4. Okay. We have one group that can come out with 1 left inside with the 2. So notice those will combine. So 6 of these plus 4 of these is 10 of these. X cube root of 2x minus 5x. Don't forget that cube there. I forgot them there. Not in the final answer, but it's good to bring them down all the way if you can. Sorry, that should be a 3. I was looking at the wrong radical. And that's our final answer. Moving on. Okay, merge into a single radical first, then simplify. So that means multiply first. So I'm going to do on the outside, 5 times 2 is 10. The a is just coming along. Cube root, negative 12 times 18. So that's 12 times 18, but the answer is going to be negative, which is 216. A1 times A2 is A3. B4, B2 is B6. And now we simplify. Remember, it's a cube root. 216 is actually a perfect cube. All right, but don't forget to bring the negative out also. So we're going to have 10 on the outside times the cube root of 216 is 6. But it's going to be negative 6. The negative comes out also. There's going to be an a on the outside. We can bring out one whole group. So that makes 2 groups. And again, some of you might want to do it this way. Bring out that one whole group. That's fine. We'll clean it up later. This is 2 groups of the b's. Now I clean it up. Negative 60. A squared, B squared. Final answer. Right, on the outside, 6 times 4 is 24. No letters on the outside. This is a 4th root. 8 times 2 is 16. C cubed, C1, that's C4. D5, D3, that's D8. Now, the 4th root of 16 is actually a perfect number also. So 2 times the 24 is 48. And then 4 divided by 4 is 1 group of C's. 8 divided by 4 is 2. 2 groups of D's. And look, everything's out. There is no radical left. All right, multiple ways to do this. Now I'm going to show you 2 ways on this one. It is a square root, So we need to multiply by radical 18 over radical 18. This is one way to do it. Okay, on the top, that gives me 3 radical 18. Okay, and on the bottom, that gives me just 18. Now I have two things to simplify. This is still 9 and 2, which means the 3 comes out. So that gives me 3 times 3 on the outside, which is 9 radical 2 over 18. And then I need to simplify. 9 over 18 is 1/2. Sorry, that should be a 9. 2, 1/2. Brain's not working. 9/18 is 1/2, and we're finished. Now, there was another way to do this. You could have simplified this. 18 breaks down to 9 and 2, right? We talked about that right here. We could have made this 3 root 2, and then just multiplied by a smaller radical. And then on the top, we would have 3 root 2. On the bottom, we would just have 3 times 2, because the radical disappears, and that would simplify to 1/2. So 2 different ways. Either way is fine. It's not much more work one way or the other. So you do what's best for you, whatever your brain understands better. Next, now notice this is a cube root, which means we need 2, 2, 2. We only have 1, 2, which means we need to multiply by the cube root of 4. Cube root of 4 to get us that 8, which is a perfect cube. So on the top, I have 6x, cube root of 4. On the bottom, I end up with the cube root of 8, which is simply 2. So I have 6x, cube root of 4 over 2. 2 goes into 6 3 times. My final answer is 3x times the cube root of 4, no denominator at all. Remember, if this is going too fast, just slow it down. Okay? Go back if you need to. Now, one thing you should always do is see if you can divide the numerator by the denominator, because you can do that with radicals. 27 does not go evenly into 128, so we can't do anything there. But 27 is a perfect cube. 128 is not. But 128 does break down to 64 times 2. Okay? So what do we have on the top? The cube root of 64 is 4. And then I have a cube root of 2. And then 7 divided by 3 means 2 groups can come out, leaving 1 inside. 2 times 3 is 6 plus 1 is 7. There is the top simplified. The bottom simplifies perfectly. The cube root of 27 is 3. The cube root of x cubed is simply x. 3 divided by 3. And now we just clean it up a little bit. 4 and 3 do not cancel. So I have that. This will cancel with one of these. Cube root of 2x. And on the bottom, I'm just left with the 3. Number 8. Again, we can simplify this. This 3 can go into this 24 8 times. Just like regular 3 over 24 can simplify to 1 over 8. We can do it underneath the radical. They're the same radical. They're both cubics. It's okay. All right? We can do the same thing with the x's. The x to the 1 can simplify, cancel with these, leaving just 3. And the y's can completely cancel. So what we're left with on the top is simply the cube root of x cubed, which will just be x. And at the bottom, we're left with a cube root of 8, which will just be 2. So what we're left with no need to rationalize, is x on the top. 3 divided by 3 is 1. And the cube root of 8 is simply 2x over 2, or 1/2 x. And that's it.